Assalamu alaikum my dear students, how are you? I wish all of you are fine. This is your new class, chemistry class. Before starting my every class, you just take your chemistry copy and book in front of you. In my last class, I told about valency. In my today's lecture, inshallah, I will discuss about another topic. So at first, go to my laptop screen first. In my last class, I told about these valence electrons, and I have solved this student activity, and this is valency on our new topic 5.2 section. So open at page number 85. Page number 85. You already know that atoms of different elements donate, accept or share electrons of their outermost energy level with atoms of other elements to form molecules. The capacity of bonding of atom with another atom of element while forming a molecule is called valency. So it's a big definition of valency. So if you write from here, the capacity of bonding of an atom with other atom of an element while forming a molecule is called valency. This is sufficient for 1 mark from here to this portion. Actually, valency is the number of electrons which is used to make a bond. Suppose hydrogen has just 1 electron, so its valency is 1, no problem. And now we will discuss about few compounds like hydrochloric acid and water and sodium chloride. So at first HCl, then water. HCl, then water, then sodium chloride. This is given in our book. In case of HCl, the valency of hydrogen is 1 because it can donate only 1 electron. It can share only 1 electron because it has just 1 electron. Valency of chlorine is also 1. Because in its outermost energy level it has 7 electrons, and its electronic configuration I wrote in my last class, so you can take information from my previous class also. So here, so it can accept 1 electron, that's why its valency is also 1. In case of water, the valency of hydrogen is 1 because atomic number of hydrogen is 1. So one hydrogen atom can donate or can share 1 electrons. So 2 atoms of hydrogen can share 2 electrons or donates 2 electrons. Individually, only for hydrogen, its valency is 1. So who should write 1? Valency of oxygen is 2 because when two hydrogen atoms share 2 electrons and individually 1 electrons, one oxygen can share 2 electrons with these hydrogen atoms. If I write its formula like this way, is 1 electron, chlorine 1 electron, then it can make a bond. Actually, to detect the electrons of individual element, I write dot and cross, but the electronic property of this electron and this electron are same. For oxygen there are 2 electrons, valence electrons here, and 1 hydrogen and another hydrogen I wrote. For this hydrogen, suppose I wrote a dot, for this hydrogen I wrote a dot. So the valency of 1 hydrogen is 1, make a bond with 1 oxygen atom, and valency of this hydrogen is 1 also. So here 2 electrons are used to make a bond with hydrogen atoms to make water. That's why the valency of oxygen is 2 and valency of hydrogen is 1. Individually 1, combinedly 2 for 2 hydrogen atoms. For sodium here, sodium chloride, in case of sodium, this sodium donates 1 electron, that's why its valency is 1, and in case of chlorine its valency is also 1 because it accepts 1 electron. So in different type of bonding, maybe it ionic, covalent or coordinate, different type of bondings, valency is the total number of electrons which is used to make a bond, So I am going to my laptop screen again. The number of oxygen atoms that can be bonded with an atom multiplied by 2 determines the valency of that atom. Suppose calcium oxide, the valency of, suppose I am talking about different type of compounds like calcium oxide. Here one atom of calcium is attached with another atom of oxygen. So the ratio is 1:1. Ratio is 1:1. Here its valency is 2. Its valency is 2. So you can say, sir, why not its valency is 1 and 1? Because in its outermost energy level, for calcium there are 2 electrons, and in case of oxygen there are 6 electron in its outermost energy level. So this oxygen tries to accept 2 electrons. So 2 electrons is donated by calcium, 2 electrons are accepted by this oxygen. That's why its valency is 2 and 2 here. So this compound is a little bit different from this compound. Sometimes we have to multiply it by 2. So calcium oxide is that type of compound. Okay, now I am going another times to our laptop screen. Some elements have more than one valency. This kind of valency is called variable valency. Variable valency of iron is 2 and 3. The difference between the highest valency of an element and active valency is known as latent valency. So there is an example is given here, and in next page some examples are given. So I am explaining, now I will explain you the latent valency and variable valency. So for this I have to remove, erase the board first. So what is variable valency? Suppose FeCl2, FeCl3. Here one atom of iron is attached with 2 atoms of chlorine. One atom of iron is attached with 2 atoms of chlorine. Here one atom of iron is attached with 3 atoms of chlorine. We know the valency of chlorine is 1. So valency of chlorine is 1. So one chlorine atom can accept 1 electron. So 2 atoms of chlorine can accept 2 electrons. So for this compound iron has to donate 2 electrons. For this compound iron has to donate 2 electrons because combinedly these 2 chlorine atoms can accept 2 electrons. Here one atom of chlorine accept 1 electron, so 3 atoms of chlorine will accept 3 electrons. So one atom of iron has to donate these 3 electrons. So for this iron is an element. For this iron has different type of valency in different compound, like this is called ferrous chloride, and this is called ferric chloride. In case of variable valency, we have to write as at later part of lower valency, like 2. In case of variable valency, we have to write eke, this eke at the later part of higher valency, like 3, for the same element. For the same element, lower valency is expressed by us and higher valency is expressed by eke. So you should understand these things. Suppose I am giving you another example, like Cu 2O and CuO. Here 2 atoms of copper donates 1 into 2, that means 2 electrons, and 1 atom of chlorine accept those 2 electrons. Here 1 atom of oxygen accept 2 electrons, and 1 copper has to donate 2 electrons. So individually 1 copper atom has to donate 2 electrons, individually 1 copper has to donate 1 electron here. So this is lower value 1 and this is higher value. For this reason this compound is called cuprous oxide. This is called cuprous, P-R-O-U-S, cuprous oxide, and this compound is called cupric oxide. Cupric means ic for higher value and as for lower value of the valency of copper, where copper has variable valency. In some compound 1, in some compound it is 2. So we should think what is variable valency. For same element, value of valency sometimes differ. So this is called variable valency. And we should memorize what is latent valency also. Suppose for this compound the active valency is 2 for iron. Active valency of iron is 2, but the highest valency of iron is 3. Suppose for this compound its highest active valency or highest valency is 3. So for this compound its active valency of iron is 2, but we know its highest valency is 3. So definition of latent valency is the difference of highest valency minus active valency. Latent valency means highest valency minus active valency. Here the highest valency of iron is 3, and in case of this compound its active valency of iron atom is 2. So what is the difference? 1. So 1 is called latent valency of this iron. 1 is called latent valency of this iron. So we should practice it a lot to identify valency, variable valency, latent valency, active valency. Actually active valency means the valency which is active in a compound formation. In this compound formation 2 is its active part, active valency. Individually 2 valency and combinedly 2. So we have to think this thing also. Here individually 1 atom of copper has valency 2. Here individually 1 copper is 1 and combinedly 2 atoms of copper has valency 2, because oxygen can accept 2 electrons. So we should think these type of things properly. I am going to my laptop screen again. In page number 83 some valency is given here, so we should memorize this type of valency. And here in case of compound formation valency is also given, so we should memorize this valency also. Suppose for sulfur its variable valency is 2, 4, 6. In case of carbon 2, 4. In case of lead 2, 4. In case of nitrogen 3, 5. So you should understand and you should memorize these values. And I have supplied a valency sheet to all of you, so you can learn from those sheet also. So thank you very much.